Hi everyone, in this video we'll discuss the last part of our 3D viewing pipeline, that is viewport transformation, and we'll discuss 3D viewing functions, that is OpenGL functions corresponding to 3D viewing. Right, so in the previous video we have discussed the 3D viewing pipeline, and we all know if I want to view a 3D scene, the first step is I have to model all the 3D objects. Model all the 3D objects, then place these objects in its location. That is, all the objects I'll assemble into a scene. This is my world coordinates. After this, you have to bring this scene under the viewing of my camera. That is my viewing coordinates. After this, you have to project these scene into my projection plane. After projecting into projection plane, I have to normalize the coordinates. I have to clip and transfer to my viewport. Right? So till projection transformation we have done in the previous video. Now in this video we'll see this viewport transformation and 3D screen coordinates. Right? So as I told, from viewing coordinate I have to project into my projection plane or view plane. Right? After this I have to do the normalization. Why I do this normalization is like it should be, that is my output, it should be independent of my devices, right? It should be independent of my devices. So I will be normalizing. Usually this normalization coordinates will be from 0 to 1, right? So uh, in 2D, this clipping, I'll say like clipping window or clipping rectangle. But coming to 3D is I have additional coordinates, right? In 2D I'll have x and y, but in 3D I'll have x, y and z, right? So this I cannot say as a clipping window or clipping rectangle. I should say as view volume. Since it has one more parameter, it becomes volume. It will have a length, breadth, and it will have a depth value, right? So I should say is view volume. So all the objects that are present inside this view volume will be in my output, right? So this view volume, when I normalize it, right, when I bring the coordinates like between 0 to 1, right, I'll get a cube, right? This is my view volume now. So whatever object that lies within the cube will be displayed in my screen, right? Now here this is my negative this is my negative z axis, right? The face of the cube, right? The face of the symmetric cube corresponds to the clipping window area. That is, this face of the cube that lies in the negative z axis will be mapped to my viewport, will be mapped to my screen coordinates. That is, since we are learning 3D, right? Every point, every point it will have, if I take a point, it will have an x and y value. Moreover, I should know about the depth value of that point, right? So here I need two buffers. Refresh buffer or frame buffer will hold the x and y value, and the depth buffer will hold the depth value of that point, right? So here this face of the cube that is along the negative z axis will be mapped to the screen coordinates, and each screen coordinate will have an x and y value and the depth value, right? Since it is 3D, I cannot omit the depth value. The depth value, it will be stored in my frame buffer. That's what it is said as like viewport transformation and 3D screen coordinate. I'll have the third value, depth value, inside my depth buffer, right? So this is a corresponding matrix. Next, coming to the OpenGL viewing functions, right? we have learned 2D viewing functions. In 2D viewing function, what is the viewing function for two-dimensional objects? It is glue ortho 2D, right? Likewise, for 3D viewing, right, the main function is GL ortho, right? And before using this function, I have to set the matrix mode, right? I have a function known as GL matrix mode. The parameter will be either GL model view or GL projection, right? So what does this mode does? It transforms from world coordinate to view coordinate, right? So model view mode, it is used to transform from world coordinate to view coordinate. And what is the use of this projection mode? It is used to project into my projection plane, right? So 3D world, world to viewing is my model view, and then into my view plane, that is image, is using the projection mode, right? So the next function is like glue lookat, right? We have discussed this lookat function in the previous video, right? I'll be sitting um, I'll be sitting at a point in world coordinate, and I'll be viewing an object. That too, in that object I'll focus at a point, at a particular point. That point is known as view reference point, right? View reference point. So the place where I am sitting, I can say as eye point or eye point or camera position, right? So this glue lookat function will have the first three parameters is related to the eye point or camera position, that is the place where I am sitting and seeing the object, right? So this first three is for the eye point. Next three is like where I am looking, I'll be looking object, and in that object I'll be looking at a particular point, right? So at vector will be where I am looking, and next three parameters is up vector, right? So in my eye point I'll have a up vector, right? Since it is 3D, this up vector will have an x value, y value and z value, right? So these are the parameters of my glue lookat function. Sitting at a point, I'll be looking at an object, that too at a particular point in the object, right? So sitting position is I, and looking position is at vector, and the up vector will be in that I position. I'll have an upward vector, that is known as up vector. So totally, since it is 3D, every position will have an x and y, x, y and z value. So totally I'll be having 9 parameters. Next is like GL ortho. As I said, for 2D viewing function is glue ortho 2D. For 3D it is GL ortho. And you know, in 3D viewing I have two types of projections, parallel projection and perspective projection. If it is parallel projection, my viewing function is GL ortho, right? And it will have 6 parameters, right? X min, X max, Y min, Y max, plus the near and far values, right? Near and far values of my set. And if my projection is perspective projection, the view volume should be GL frustum. View volume should be GL frustum. GL frustum, X min, X max, same. Parameters will be same. We'll discuss what is this GL frustum. Right, GL frustum is nothing but an infinite pyramid. Right, GL frustum is, that is frustum is infinite pyramid that is made to finite by adding two planes. By adding two planes, near plane and far plane. So what is frustum? It is an infinite pyramid. This infinite pyramid I should make into finite by adding two planes, that is near plane and far plane. Right? Always your view plane will be close to your near plane. Right? This is known as frustum. Frustum